So yeah, I will talk about Barrel and mostly about how Barrel has been integrated in the platform because it's entered in a semi-production. Yeah, so it entered in semi-production recently. So to present myself briefly, I'm Benoit Chesneau, so I'm craftsman, mostly working since 20 years in the database world and P2P platform. What I'm doing for my customer is I'm building endpoints, data endpoints, custom data endpoints based on existing database or something that I could create from time to time. And Key Multimedia is my own company, my corporate interface, and I also a member of the Erlang industrial user group, which main goal is to help to create that foundation, that Erlang foundation that will come very soon. Barrel is about to allow people to use to have a better usage of the data in the microservices. And when I'm speaking about microservices, this is more about mobile services because a microservice is just one machine somewhere, but we can think mobile or anything as also microservices that you can export if you add Erlang on iOS or Android, which is quite possible today. What is a good microservices? You have to ask yourself when you're building a microservices if your service is a microservices. Does your service do only one thing? Is your service autonomous? Meaning, can it work without any dependency? Can you launch it, span it anywhere, multiply it if you want to? Does the service has its own data? Because when you are connecting your services to a database, there are good chances that your database will crash at some point. Is it able to survive, or at least is it able to say to your clients that it won't accept any more of the service? This is something that you need to think about. So your microservice, in short, should be isolated, should own its own data, should be resilient, being able to be restarted, being able to handle some latency of the storage, etc. It should be also able to communicate with other microservices asynchronously or with the current asynchronously because then you're able to queue the message, handle back pressure, etc. And if you look at that and you look at the definition of actor in Erlang or process in Erlang, this is basically what is doing a process in Erlang. And we can also consider that a process in Erlang could be a microservices in your platform because this is something that you can communicate, transport over the network, etc. In fact, when you're building a microservices infrastructure or mobile infrastructure, everything is about sharing the data between your storage and your microservice, and then your microservice to your other microservices on the mobile for your customers or the computer of your customers. For example, if we are talking about messaging, when you build a messaging system like each does or MongoDB does, when you see at their infrastructure, these are independent nodes accepting message and potentially discussing with other services. You can crash one node in Jabberdy or MongoDB, and you will still be able to accept the message from your customers. So there are two ways. The usual way for people to handle their microservices is having your database, the client call a web service, an API, and your microservices, your application is querying the database and provide the response to the request of the customers via the API. The problem is what happens when the connection to your database is slow or crash or absent. Then your microservices will stop. And what happens? You're blocked. And even if you have your magnifical Docker infrastructure, if you don't make sure that your data are local to your Docker at some point in memory or in semi-resilient storage, then you're dependent, in fact, from your database. And if the database crash, then everything crash. So you want to be resilient to disconnection, to possible disconnection of your database or crash of your database. The vision with Barrel, which is shared with others, is rather than having to query the database always, you keep a local storage on your microservices. You could tell me this is just like caching, but caching is about querying your database, putting some data, and from time to time ask your cache if I have it in memory. You don't query your cache. You don't make any complicated query like an SQL query or whatever. You're just querying a key value depending on the hash and retrieving that within the cache. And if it's there, it's okay. If it's not there, you will have to query the database. And then the problem is happening because if your database is disconnected, then your cache is here for nothing. You can't make sure that you have all the data. So the main goal, the main objective in Barrel is to put the data near your application and to query it like it was a partial view of your storage. So like I'm saying, it's bring and keep your view of your data near your application. So the principal core concept quickly of Barrel is to focus on simplicity. This is a documented-oriented database. I will explain shortly what this is. And this is automatic indexing. Because the thing that you don't want to do when you are building a services is to always work on the migration of your data. When you are on building your service, or even over the time your service will evaluate, you generally don't want to migrate. Migration policy in database storage is a point of failure most of the time. You have to make sure that your policy is okay. You will have to test it in quite real condition, and sometimes it will just crash, or sometimes we just delete the backup when doing that operation, or put your test data in production. So Barrel is doing automatic indexing. So any data that you put into your system is indexed by default. Then you can filter what you want to index at the end. But by default, everything is indexed, very simply. So when I'm saying document-oriented, this is a document. These doc are simple maps. And in fact, they are following the JSON specification. Keys are not string like this, but binary strings. And UTF-8 binary, and other literals are JSON literals. And because we are indexing map, if you look at a map or a JSON or nested JSON, in fact, this is quite like you add a tree. And when you index your JSON, you're indexing the tree or a number of paths in your database. And this is basically that. If you take that first JSON, which presents a location, a couple of countries, quarter, etc., you can split it in a tree, and you can just index that tree in your database. And you can do that for any JSON, and then you have position. Your list become an integer position in your list that you index, etc. And then you can access by path to any database, to any data in your database, in the document. So, for example, to access to all the documents in Germany, I could access to the path, location, country, Germany, and do anything like this. This is that simple. And when you want to merge, or if you just want to build another SQL system, you can build it over that because you have all the primitives to do the merge or anything you want in memory or disk. You just query your path in reverse way by value or not, because we can say if we are looking really on Germany keywords, then it would be faster to start by the end of the path in your index rather than the beginning, because it would it would reduce the number of results, of course. Such like thing. So any document that passes in Barrel is automatically indexed like this. The other key concept of Barrel is it's local first, and data are synchronized with other storage. So the main goal of Barrel is to be in the middle of your between your application, the client, and your database, and make sure that you are able to replicate between different cluster, different data center, or different machine, or different mobiles, etc. It replicates to and from any source. So it's a leader, follower, follower, leader, master, master, whatever you call it. It can replicate in any sense. You can replicate both pull and push. So you can, two nodes can replicate each other at the same time without any conflict, or at least the conflict will be kept. This is a partial view, so something that you can build in Barrel. So you can have one node querying that another node and filter by path depending on the index. So if you just want to make a shard of your data, keep all the data corresponding to your office, or all the data corresponding to a country in a machine, or to a user in a machine, you can just replicate from a larger node, or for a database like Oracle or Postgres or whatever, and put that data locally on your nodes and handle the replication with other nodes, or do some query locally, etc. Barrel is available as library in your Erlang application, and when I'm saying Erlang application, this is in very large term. It can be Elixir. There will be soon a new version of the binding for Elixir. It can be in LFE or anything on the Vim, in fact. It's also available as microservices via HTTP1 for now. HTTP2 is coming really soon now on WebSocket, or via Erlang distribution also. So you can just use Barrel like Nesia and start to use the Erlang distribution to replicate the data. This is a peer-to-peer system. My point is not to build by default a large-scale database. Like I said, my main job for me is to propose endpoint to customers and to propose custom solution of data. So the Barrel is the unit, and when I'm saying a Barrel, this is maybe 100 gigabytes of data local that you have local on your node, or it can be 16 gigabytes if you want it in memory. And to propose the semantic to allow the distributed transaction. So if you want to do a Corfu system, you can say, I'm sending a replication rules to my other nodes, and I will wait at the end of the chain of my replication chain. And then you have built a Corfu system if you want to, or stuff like this. Or listen on any event of the database. So you can do different things. You can do, like I said, every peer fork the masters, and then you can update. You can disconnect them. Each node's work offline, and when you want to reconnect, you can reconnect the node later, and they will replicate the change. It's useful, for example, if you are organizing an event on different boats, and one part of the event is on the ground, then each node will handle the activity on the boat and on the ground, and when they are able to connect, they can replicate each other's data or anything like this. And you have also a CRDT semantic. So by default, Barrel is just storing your conflict, and you are able to know if a conflict happened and solve it, or you can put some callback inside the database and automatically, using the algorithm you want to, manage the conflict-free system. There is no vector clock like a CouchDB, because everything started by a fork of CouchDB before I got fed up and rewriting that from scratch. This is a revision 3, and So each time you are creating, so when you have a branch, this is like in Git, it means that you have a conflict inside your documents. So each time you are creating a conflict, a new branch is created, and you are adding that new revision to that branch. And if you continue to edit that branch, so every time you pass the revision, last revision, some kind of blockchain, whatever, then you can keep the causality because you know that this document, this revision has been edited based on the other one before, etc. Like a vector clock. The difference with the vector clock is the vector clock doesn't scale really when you want to work in offline condition. You won't have too much divergence in your digital clock. Even with dotted vector clock, it's better with server-wide clock, but not that much. So a revision tree allows you to keep that tree very short. And also, I forgot to say, a revision is just a hash of your content. So if you have the same revision created at two places at the same time, which can happen if you have a mobile that was connected to a load balancer, try to update to another to one node, didn't get the response, and then retry and write to the other node that has been made available by the load balancer, then you will have exactly the same write. When the replication will happen between the two nodes, it will know that this is the same revision and doesn't try to fetch the documents. So it will save you some bandwidth, something like this. I will pass that because it's not real things. So everything is built in Erlang, and the first thing you should ask yourself when you build a data platform is why you would do that in Erlang. Because, yeah, Erlang is slow, apparently, according to some people. Erlang, what you can hear is Erlang is only done for communication protocol. This is an orchestration platform. This is how it's used, and this is mostly how you do that. I should do it in Rust, even if you hear some Erlang's user of the year that are now doing Rust. I should do everything in Rust today because this is faster, this is more lower level, and this is what you want to. And indeed, if you are checking Erlangs today, and if you want to do some file, if you want to write a B tree in Erlangs, you will have to use that file driver by default of Erlangs, and this is only one process, so every write and read will be serialized to that process that maintain that file descriptor until you maybe create file in read-only mode. And there is no access by default in Erlangs to lower level things in Erlangs, like you can't do memory mapping or access to the block cache in the file system. Any lower level API is not accessible by default in Erlangs. But anyway, Barrel, like I said, is mostly a more data orchestration service than a database by itself. It doesn't try to be Postgres. It doesn't try to be Oracle or whatever. It will use them when there is a need for them, and it will use other query. The goal is to bring your data near your application, offer you a way to index that, and the main goal of the indexation is to filter the replication later, or to filter what you want to keep on your node. And anyway, in Erlang, you have the NIF, native interface that allows you to interface any C code. So if you want to have access to that lower level API of the file system or the memory, you can do that, write it. Before to continue, what I'm writing in, we'll describe a little what I'm writing in Barrel. So the first unit is a document, and document is consisted in multi-revision if you update it multiple times, and the metadata, which is keeping the revision tree I described. Each time you update a document, in fact, you have a read, modify, write operation. It will get the latest metadata, check if there is a conflict, and if there is a conflict, it will tell you by default. and then you update that metadata and store it with the revision. And that is quite challenging in Erlang to do that without having a proper lock API or whatever. I'm also storing a log of events. So each time a document state change, each time you have a new document revision that can be used without any conflict, a new event is created. So you can listen on the event, and this is how the replication is working. Is listening on the database events and pass the data between your nodes, or even the indexation. The indexes, each time a new change is provided by the database, they are indexed. The indexer enter in action and start to index synchronously your document. You have also some blobs. That part is very minimal right now, so you can attach some binaries to your documents. Which is useful is like one of the current cases where Barrel is used is to create secure messaging systems. And we are only keeping the metadata needed to allow to the clients to recover the message he sent to them or he received on the platforms. And we are storing all the messages as blobs, encrypted blobs attached directly to the document. Which offer one advantage. You are able to replicate the metadata plus the real message or the blobs at the same time to the other node. So doing it along in Barry is not an issue. Like I said, it provides connectors for the other data storage. For any SQL library like Oracle or Postgres, etc., it's using the ODBC API from Erlang. So I'm doing the very basic, in fact, when I'm querying a remote storage. I'm just querying when you write a connector, this is a way to tell to Barrel, this is how you will get that document from your table. So you don't have to modify your table in your database. You create from your table a document that will be replicated. Barrel will just create some small information in your database to keep the list and to keep the index, so they will be also stored. And then you can use your giant database, your giant Oracle that you already know how to replicate, or Cassandra or anything. So because you know how to make it very scalable, you will be able to store each Barrel information in that node and still use the replication, etc. For the local storage, I'm using RocksDB. I wrote a binding that you can find at that URL. Contrary to the other driver that you can find for the database, it's using .inifs for to maintain a pool of threads to make the call to the database, which are supposed to be fast. And RocksDB is actually used also for the memory database because I didn't have the will to write because one of the things I want to that I will talk a little later is to distinct the write from the read, so you can read while some other people will be able to write. And to do that, you may want to access to a stable view of your database, a snapshot of your database. And then this is something that is provided for free by RocksDB. And I just had to reuse that in memory. In UTS, I wrote, you can find it also on GitLab, I wrote a library that is called memstore, and that offers you also a way to do MVCC, multi-version control concurrency over ETS. But I'm not using that right now in Barrel. So one of the challenges that I want to, because writing a database finally is very simple. You can write it in maybe one day if you just consider to store on the file system. So you can store any blobs on the file system, provide a basic index based on the path on your file system, and then you have your database written. But then the problem happens if when you want to receive a lot of concurrent connection to your database, of a lot of requests. And one of the main difficulty when we are writing a database is to make it resilient and to be able to accept a lot of concurrent connection. And also, you really want to know, at least this is one of my goals, you really want to know to say to the client, stop to query me, because I can't accept you more. I don't want to crash to say, so I know that the general philosophy in Erlang is let it crash, but from time to time you don't want to crash. You just want to say to the clients, stop, or you just want to know that when you will be on the point to crash, you want to be able to span a new process. You want to be able to handle maybe that concurrency and start to span new processes on new machine. So one of the goals in Barrel is also to anticipate the resource usage of nodes, so we can return early the result to the client. And that control is applied to all the resources in the nodes, which also us to do active throttling, but also to do some back pressure. So to do some back pressure, but also to dynamically handle the loads, span new process, increase your pool, or whatever. And to do that, the initial try, mostly at the prototype part, was to use a worker pool. So we were able to span multi-processes that will handle the load, but the worker pool is static. So at the beginning, you set your number of workers, and you will use that number of workers to handle a query. So it's good to limit the concurrency, but it also creates a bottleneck because you have little control on your queue. You don't know what is happening on the queue that is waiting for the request to do on your worker, and also you are not able to interrupt the connection to the queue. So you would have to create another level before going in the queue to break the circuit if you want to. But I want something more simple. Also, the problem with pool like worker pool or pool boy or any other pool using the same system is this is very hard to debug, because most of the time the crash will happen in the pool, in the process of the pool. And so you will have different logs, you will have to do some tracing extra, which is more difficult than just getting back the result immediately. Which is something offered by EC Proxy, a library from Duomark. Forgot to put the links, but if you go on Duomark repository for that things, this is mostly a fountain of process. So each time you need a new process, it will span a new process depending on the load, and also able to handle back pressure, but in the reverse way. It handles back pressure by timeouting, mostly. So this is not what I really wanted to do. That and the thing that we would have to do a lot of work on that library to have it working inside Barrel as of today. So we figured that what we wanted is dynamic regulation. Yeah, how much time?
5 minutes over.
5 minutes? Ah, okay. Okay, by finishing. So you have the client jobs that are handled independently. We want active and passive regulation. What I said, we have something that is at the beginning of your configuration. You are setting the number of requests you want to accept on that node, on that database, and then it will set a certain logic inside the nodes. We want flow-based programming for the worker, so we want to have our pending requests handling their queue and the worker handling their own queue and eventually span them. And as broker is partially fit the bill. But this is not, for now it's doing its jobs, but it's quite complicated to handle, mostly because it lets us too much choice to supervise our worker, etc. And we are not sure. I'm not sure that we achieve something very, very stable on the long term. Yes, so this is single writer multi-reader patterns. there is one process that will handle at the end the writes, and we do most of the work outside of the process. In fact, we are trying to parallelize everything before really writing to the database. And indexes are processed asynchronously, listening on the change feeds. Yes, when we are using the Erlang distribution, important part is we don't want to directly send the message to the nodes, to the process that subscribe to the nodes. So each process are subscribing locally on their nodes, and then this is that node that will subscribe to the database node, and the database node will send to that node, and they will be dispatched locally. So we don't go too much over the bandwidth. Yes, Erlang distribution can be switched. We have actually in the pro version we are using Partisan for that, but we are also testing some other things like libp2p and other protocol. And I finished. So there is one version coming on this month, and the other, then after that, the goal is to increment every month with a new release. And in next versions, you will have WebSockets, which are arriving with the new Acne version, and experimental gRPC coming next month. That coming also with HTTP2 inside Acne. And I finished.